Today we will assemble this lithium battery, the lithium battery automatic charging circuit. We'll solder while explaining. After watching, you can make one. This is the brain of the entire system, LM358 integrated circuit, which has two operational amplifiers inside. We connect it to voltage converter mode to monitor the battery voltage in real time. Once the voltage reaches the full standard, it will cut off the charging circuit to prevent overcharge. Pay attention to the notch direction of the chip. It won't work if the direction is reversed. We solder a 100 kΩ resistor. It acts as a feedback network in the circuit and cooperate with subsequent components to produce a weak hysteresis effect. This hysteresis makes the converter operate smoothly, avoiding frequent on-off caused by battery voltage fluctuations. Eliminate jitter. It makes the charging and discharging actions clean. Now, this blue 10 kΩ potentiometer is on stage. It is the precision regulator of the entire circuit. By rotating it, we can precisely set the charging cutoff voltage. Later during debugging, we need to adjust the output voltage to 4.2 volts. To set the output voltage to 4.2 volts steadily. It can be said that this small potentiometer determine how full your battery can be charged without overcharging it. Next are three resistors of 1000 ohms. Although they have the same resistance, but each has its own function. The first one provide a suitable working current for the Zener diode. The second one forms a voltage divider circuit with the previous, which is responsible for sampling the battery voltage. The third one is used to limit the control current flowing into the transistor to protect the downstream components. The same structure, but different missions. This is a 3-volt Zener diode. The black ring on it is the negative pole. Don't install it backwards when soldering. When the reverse voltage exceeds 3 volts, it is clamped at 3 volts. Using LM358 to establish a stable voltage reference to enable the converter to accurately judge the battery status. This is the fourth 1000 ohm resistor in the circuit. It connects between the power supply and the indicator LED. Its function is simple but important. It limits the current for the LED, ensuring the LED works at a safe current, which is bright and long-lasting. Next is the famous BD140 transistor. It acts as an electronic switch here. When LM358 determines that the battery is not full, it will output a low-level signal, which makes BD140 conduct. Current flows through it to the battery when the battery voltage reaches 4.2 volts. When the LM358 signal flips, BD140 will be turned off immediately. The charging circuit is instantly cut off. This transistor is the iron gate for automatic power off. The resistors we are soldering are 470 ohms. A 470 ohm resistor. They are connected in series with two different colored LEDs due to different resistances. The current flowing through them is different, thus resulting in different brightness of the two indicators. So we can intuitively distinguish between charging and full states. The design is very ingenious. Next is the green 5mm LED. In circuit design, green usually represents completion when the battery is fully charged after the circuit is automatically powered off. This green light will light up, reminding you that you can safely remove the battery. Following it is a 100 ohm resistor. A resistor and a red 5mm LED. Red symbolizes in progress. When the battery is charging, the red light is always on, and the red light goes off. The green light turns on. The red and green switching state is clear at a glance. This 100 ohm resistor is still limiting the current of the red light. Now we are soldering a 3.7 volt battery holder. It will hold our common 18650 lithium-ion battery. Finally, we solder the terminal. This is the power input port of the circuit, used to connect a 5-volt DC power supply, such as a mobile phone charger. Positive pole connects to one end of the terminal, and negative to ground. All components on the circuit board are in place. Look, when we connect the 5-volt power supply, adjust the potentiometer to be no load, and the output voltage is precisely 4.2 volts. We insert a depleted 18650 battery. The red LED lights up immediately, indicating that it is charging. As time goes by, the battery voltage gradually increases. When it reaches 4.2 volts, the green light turns on, and the red light goes off. The charging circuit is automatically cut off. The whole process requires no manual intervention. It perfectly realizes automatic power-off protection. This is the charm of electronic DIY. With a few simple components and a serious heart can create an intelligent system.